Okay, tangents and normals, tangents and normals. Find the tangent to this cubic where x equals 1. I'm going to encourage you, even though it doesn't need to be perfect, well, it's not going to be anywhere near this thing here because we can't see it, but just go, rightio, I've got a cubic, it's looked like that, and I want to draw a tangent where x equals 1. Right. So I need to find the slope of the cubic at 1, and then the tangent's going to go through that point. Okay. So just sketching that, getting it right in your head, means that it's actually not that much of a challenge. We're going to start, because it's a tangent, our tangent's going to be in the form y equals mx plus c, because it's a straight line. We are going to need to find m. We're going to use the gradient function, which is y dash 3x squared. And we need to find the slope where x equals 1. 3 plus 2 is 5, minus 2 is 3. We can go, therefore, m equals 3, y equals 3x plus c. Remember that function, the tangent passes through this point where x equals 1. So we need to find the point by x equals 1, so that will be y equals 1 cubed plus 1 squared minus 2 plus 4, which is 1 plus 1 is 2, 4. So the point 1, 4 lies on the tangent, and I'm running out of room. So by substitution, 1, 4 goes into this thing here. We're going to use that point to find c, like we have done since grade 8. So when x is 1, y is 4, c equals 1. So our tangent becomes y equals 3x plus 1. There's our function. That's that function. It's time to get your calculators out, or Desmos. And there it is. So that's our cubic. And there is our tangent. And you can see how it's a tangent at the point 1, 4, which is this 1, 4 that we found. Okay. Find the tangent that has a slope of 4. Right, so that's a different style of question. Yeehaw. So we're thinking, I've got a parabola, and at some point there is a gradient of 4. So it's steep. I need to find this point. I don't know what value of x it is, but there's a value of x where this slope is 4, and then I need to find that as a point, and away I go. So again, quick sketch can help you calm yourself so you know what you're doing. So that's what I should have pressed. So tangent must be in the form y equals mx plus c. We actually already know the slope. Slope, my gosh, equals minus 4. So we already have y equals minus 4x plus c. Can you see that all we need to find is a point? We need to find the point on this function that has a slope of minus 4. Find gradient. function y dash. So that's going to be 6x plus 2. Need slope of minus 4. Let's subtract 2. Okay, so we need to find this point, which is minus 1 something. So by substitution, we're going to put it back into this thing here. So we know where the slope is minus 4 on the x, but we don't know the y. So y equals 3 times minus 1 squared is 3, and then minus 2, and then plus 5. 3 minus 2 is 1, 1 plus 5 is 6. So there's our point. Minus 1, 6 lies on tangent, so by substitution, I've done it again, I'm running out of room. Remember, this is our tangent line, y equals, and we're going to go when x is minus 1, so let's just cut that out and go, that's going to be a plus 4, y is 6, so c equals 2. So our tangent is y equals minus 4x plus 2. And as per the last one, you can see our parabola. You can see the point there that we've found that has a gradient of negative 4, and then our tangent goes through that point. So ideally you'd be able to check that in your graphics calculator or Desmos yourself. Oh, find the normal to the function. A normal, what's the word normal? It means perpendicular. I'm doing this one on purpose. Look at those silly numbers there. It doesn't really matter. They're all the same. The big numbers don't scare us. So the normal. So it's a normal's in the form y equals mx plus c. Let's find m. So I need the gradient y dash. So what's that going to be? 7x to the 6 plus 6x to the 5 plus 1. Find the slope where x equals 1. 7 plus 6 plus 1. What's that? 14. So, therefore, m equals 14. Tangent becomes y equals It's not a tangent. Somewhere you're going to go m1 times m2 equals negative 1. So it's going to be minus 114x plus c. What do we need? We need the c. Find the point. It's going to be 1 something. So 1 something y equals. So it's going to be 1 to the 7 plus 1 to the 6 plus 1 plus 2. 1, 2, 3, 4, 5. So it's the point 1, 5. 1, 5 lies on the normal. So by substitution, it's not going to be y equals minus 1 on 14x plus c. This 1 will just be there, and that y will be 5, so c equals 5 and 1/14. Right, just squeezing this one in. So our normal becomes y equals minus There's our normal there. Again, starting with a function as silly as that, clearly we had to end up with something a little bit silly, but those numbers are not hard. The process is the important thing. If you understand what's going on, you'll be right. So, who knew what that thing was going to look like? But that's it there. That's it there. And you can see that the 0.15, that's this point that we found where x equals 1. So that validates it because you can sort of see here that the slope of the curvy one, the polynomial, and the normal, that's a right angle in there. It even looks like a right angle. Okay, tangents and normals. We do lots of tangents and normals. These are the easy type polynomials. We do them with exponentials, trigonometric functions, you name it. So get used to it now and do some practice.